Hi, everybody. So this is just a little extra notion that will help you kind of understand how certain topologies are related on the same set, especially if we're looking at something like this example, wrong thing, the example right here, or this finite complement topology example. So suppose I've got two topologies on the same set. Let's say tau and tau prime are topologies on the same set X. So in that sense, I mean that they're two collections of subsets that satisfy these three properties here. So I can compare the two. So I will say, if, say, maybe I'll write this. If tau is contained inside tau prime, we say tau prime is finer than tau. So you think about this as tau prime has more open sets. Kind of conversely, we also say in the same sense that tau is coarser than tau prime, which means that tau has fewer opens than tau prime. And generally, we say these two topologies, tau and tau prime, are comparable, comparable, if either tau is a subset of tau prime or vice versa. So two topologies do not have to be comparable. So for example, look at the space of two sets or two subsets, or a set with two elements, where this one has this topology, I'll write it like this, and this one has this topology. So this will be, call this one tau 1. This topology is nothing, the set containing A, everything, which I'll write as A comma B. And this one is nothing, the set containing B, and everything. These are not comparable, right? Because this one has a subset that tau 2 doesn't have, and tau 2 has this subset which tau 1 does not have. So with this in mind, we can look back at this example over here and say that, well, this finite complement topology, is definitely coarser than the reals with the standard topology. Why? Well, every subset here is going to be open over here. But conversely, if I had something like the open interval from 0 to 1, it's open in the standard topology, but it's not open in the finite complement topology. Because its complement, well, it's not finite, it's not all of R. This is equal to minus infinity to 0, union 1 to positive infinity. So this one contains more open sets than this one. So the last thing I'll leave you with is, so for this example, when you're going through and listing all the topologies on this 3-element subset, or 3-element set, you can also label them according to which ones are comparable or not. So for example, this is basically the same thing we just did. These are not comparable. But this one is coarser than this one. And so on. So I think that'll be all I really wanted to do for today. Next class, class, whatever that means, the videos for Wednesday, I'm going to talk about a basis for a topology, which will sort of elucidate what I meant by a topology being generated by a family of subsets. All right, guys. I will virtually see you on Wednesday.